Alright, this is video 1 of the online notes for my ICC class. Alright, so 2.6 is where we're starting. We finished 2.5 before we went on break. And so 2.6, marginal analysis and differential equations. And so we're going to do this in sort of little clips. And so you're going to go on and watch this at home and fill out the notes that I've given you. Alright, marginal functions. Marginal cost, revenue, profit is marginal analysis. It's the study of the change in economic quantities. Alright, so it's a process or an analysis of approximately using the derivative to figure out how much cost, revenue, process, or it can actually use any function you want, but is increasing and decreasing. And in this class, we keep it the simplest. We approximate how much you increase and decrease by 1 unit. Alright, like I said, that's what we're going to do in this first bit when we talk about marginal analysis. Alright, so we're going to do marginal analysis on cost, revenue, and profit. Now, you can do a marginal analysis on other types of functions. Those are just the 3 we're going to do in the simplest case in this class. Alright, marginal cost function. Alright, it's just an application of the first derivative. Alright, so when we find the marginal cost, which I'm going to label capital C of x, it's the derivative of the cost function, and what it does, it approximates the change in cost when we go from producing x, where we're currently level, to plus 1. So it's the difference in the cost for 1 unit. Alright, so it's the additional cost when we produce the next item. It is an approximate, right? It is an approximate change in the cost. It's not exact, and we'll look at an example of that. Oftentimes, we'll use an application as we'll sort of rearrange this a little bit. I'm going to solve for the x plus 1, so the cost at the plus 1. Right? And that can be approximated by taking the cost at the x value and adding to it the cost at the derivative. Right? And that's just rearranging. I'm actually going to move this cost over to the other side, and that's where this current level of production, right? This is the current cost. This is the approximate change in cost. All right, again, guys, you're going to have to bear with my writing on this. It's all done on a tablet with a pen, and so bear with my handwriting. All right, so this, again, this part is the additional cost to produce the x plus first. Alright, and again, it is an approximate additional cost. Alright, so if I take the current cost plus the approximate additional cost, well, that'll give me my approximate cost at 1. Alright, we'll look at applications, what we mean by this, and compare it to the actual cost. Alright, so an example of marginal analysis on the cost function. Alright, so an electronics manufacturer produces MP3 players. Alright, so that's the x value. Alright, number MP3 players in production. Marginal cost. Well, marginal cost is just an application of the derivative. So it's just find the derivative of the cost equation. All right, power rule. So I just, simple rules. That's 0.003 x to the second minus 0.16 x plus 40. All right, so there's my marginal cost function. Right, find and interpret. Now, marginal cost is marginal analysis. All right, so actually it's the interpret part that's just as important in this application as the solve part. All right, so this is their current level of production. Right, that's the x value. X is 200. They're currently producing 200 MP3 players. And so if I take my marginal cost function, which again is just the derivative, and plug 200 into it. Alright, so again, I'm going to plug it into that equation we found in part A. When we do, it comes out, so again, I'm plugging it in here. It comes out to 20. Now, that's just the find part. Now, the interpret part. And the interpretation, like I said, is important because we're no longer looking at a derivative as a rate of change. We're now looking at a derivative as an approximation of an additional cost value. And so what this means, this $20 means, if they decide produce the next item, if they produce the 201st MP3 player, the approximate cost, additional cost, is $20. It doesn't mean 201 players cost $20. It means that one more, going from 200 to 201, cost them about $20 more to do that. That's what that means. All right. And again, it is an approximate cost. All right. Well, now we're going to approximate the cost to produce that. So this is how much more it'll cost them. And so this is using the other version of the formula. I want to know how much it costs to produce 201. All right. And instead of going, I know we could, and we will in a little bit go back and plug it into the original equation. We're going to use the marginal function to do this. And so what you do, well, I find my cost at 20, which they already should know that. That's the current level of production, but we don't, so we're going to have to plug it in and find it. So we find the cost at 20, so this goes back into the original. So you'd go back up and plug 20 back up here in the original. Add to it the derivative at 20, which we found, and I keep saying 20, this should be 200. Sorry. The cost at 200 and the derivative cost at 200, so the additional costs. Alright, so we have to plug 200 back up in here to find the first piece of that. And when you do plug that in, it comes out $6,100. Alright, and then we found, so that's how much it costs to produce 200, their current level of production. So right now, they're producing 200 MP3 players. It's costing them $6,100. Using marginal analysis, to produce one more, it should cost them $20 more, about. And so, the cost to produce 201 items is about $6,120. Alright, again, based on marginal analysis, that's how much it should cost to produce 201 items. Alright, and marginal analysis is usually pretty accurate, especially in these types of equations where they're simple polynomial types. So we're going to compare, the last or the second C here is comparing how good of approximation was the marginal analysis. Alright, so we're going to find the actual change using the total cost function. So again, we're going to go back and use this cost equation. So I'm going to write it down here. We're going to use the cost, the original cost, so that one in the problem. This is just so that you have it to look at. So this is the one we're going to plug our numbers in. Alright, and so now we're going to find the actual. So there's no approximation here. I'm going to take my cost function, plug 201 in, take my cost function, plug 200 in, which I already have. That's 6,100. Alright, so I still need to find that value. Alright, so when I plug 2001 into the original cost equation, not the derivative, remember going back to the original, it comes out $6,119.98. So the difference is actually $19.98. So that's actually how much the cost was. We approximated it as 20, right? This is the actual cost for 201 items, 201 MP3 players. And so marginal analysis was pretty good. You'd probably, if somebody owed you $19.98, you would say it cost, or they owe you $20, right? Or if an item costs $19.98, you'd say that item cost you $20. So it's within 2 cents. It's a pretty good approximation. And so, like I said, this is how marginal analysis is used. They use the derivative to approximate this cost. And the one reason why is because the derivative is a little easier to plug stuff into. It's usually a little more simplified, and they can do this for more than one item. They can do it for many items. And it's just a little quicker. Alright, marginal revenue. So marginal cost, marginal revenue, and marginal profit. They basically all work exactly the same. The only difference is revenue is just talking about number of items sold. Alright? And so, again, the process is identical. Alright, marginal revenue is just the derivative of the revenue. Alright? It approximates the net, the additional revenue when they produce the next item. So it's the difference in the revenue at one more item from where their current level of, so X would be their current level of production, they're going to produce one more, and marginal revenue finds the difference in those two. How much more will that one cost, the total change to produce that much? Or, like before, we can use it to approximate that revenue cost at that one additional item. Alright, which would be, again, the revenue at their current sales, plus the approximate additional revenue when they produce one more. And so you take the original revenue, add to it the derivative. So again, this would be their current level. This would be the approximate. So again, this is the revenue at X. This would be the approximate additional revenue for the X plus 1 item. Alright, so when you take those and add them together, that approximate how much revenue at 1. And so we're going to do an application of that. Alright, similar to what we did, like I said, in the earlier sections. The first example. The only difference here is revenue instead of cost. Alright, first thing we do is find the total revenue function, so you have to remember how to do that. Remember, revenue is price times quantity, where price is given to us in the application. Price is so that's the price revenue equation, or demand equation. Alright, so we're producing speakers, the price P is how much the speaker costs, X represents the demand. So this is the price demand equation. So again, price is changing, right, based on demand, and so we're going to plug that in for price. Alright, so revenue is that price demand equation times another X, and then I'll distribute that X. So revenue is going to come out negative 0.02x squared plus 400x, and so there's my revenue equation. So revenue equals negative 0.02x squared plus 400x, and that's the revenue function we'll be using for the problem. Alright, so that's going to give me out the dollars in revenue for the item sold, for the speaker sold. Alright, so part B, marginal revenue function. So marginal revenue is just the derivative of the revenue. Alright, so this is just a simple derivative. I pull 2 out, so I get negative 0.04x plus 400, and so there's my marginal revenue function. And so it's asking you to find the derivative at 2000 and then interpret it, and again, we want to interpret it in terms of marginal analysis. Alright, so we're going to find it and then interpret it. Alright, so the derivative at 2000, so I'm going to plug 2000 in my derivative, and so that's going to come out to 480, and again, now it's the interpret. What is that telling me? So that's telling me if they sell one more, they're currently selling 2,000. So if they, actually another way to put it, increase the sales of speakers from 2000 to 2001. Alright, so that one more, specifically that one, if I picked 1,000, I'd get a different answer, going from 1,000 to 1,001. It's specifically 2000 to 2001. That additional one, that specific one, then revenue will increase by about approximately, again, there should be some word to indicate that it's an approximation, by about $480. Alright, so again, that's how much that one speaker is going to add to their revenue. Alright, so when they produce 2001, that specific one, they'll get about 480, about, it's approximate, $480 more in revenue. Alright, use marginal revenue to approximate the revenue equation. Alright, so this is the second way we go do a marginal analysis. So I want to, again, instead of plugging, and you could plug it into the original revenue, kind of compare and see what the difference is. We're not in this case, we're just going to use the marginal revenue to approximate, which means I'm going to find the revenue at 2,000, which they would know that. They would know what their revenue is. And then add to it the derivative at 2000, which is the approximate additional revenue when they produce the 2001st. Alright, so I do have to go and plug that one back into my original revenue equation. So I got to go back up here and plug in 2000. Alright, so back up there, I got to plug in 2000. Alright, so I'm going to take 2000 into my revenue equation. When you do that, it should come out a fairly big number, 880,000, and then the approximate additional revenue to produce the next item is 480. Alright, so when they produce 2001, revenue should be about $880,480, which is actually pretty close. If you go and actually plug this in for real, it's off by 2 cents. Alright, it comes out $880,048.02. Alright, so this is a pretty good approximation. That's how much revenue they generate from producing 201, from selling 201 items, right? Revenues from sales. Alright, the last marginal revenue is marginal profit. Again, same song and dance, same thing. Marginal profit is the first derivative of the profit function. It approximates the change in profit when the X plus 1 item is produced. So again, they're currently producing X. They'll produce one more and sell one more. When they do that, this would be the approximate additional profit. And a profit can come out positive, it gain, can come out negative, a loss, and it can come out zero, there's no change. Alright, so marginal profit is the derivative of the profit, which again approximates the change in profit to the next item. Alright, so the current level of production is X, and then this would be the plus 1, and that would be the difference, and that's what marginal profit approximates. Alright, again, another way we can rewrite it is profit at the next item is approximately profit at the current level plus the marginal profit. Alright, when we, again, this would be the marginal profit, what we guess is the little bit more that they'll make. Alright, works the same way as the cost and the revenue. Alright, so no difference in that. Alright, so I'm going to do a problem from your book. Alright, this is problem number 8 and page 266 from your textbook. Alright, Crawford County Computing finds that the weekly profit in dollars for the production of laptop computers is given by that quadratic. They currently sell, so this is their current level of production. So X is currently 9. Alright, the current level of production is 9. So A is asking for the current profit. So let's just take your profit function, plug a 9, the original. Alright, so plug 9 into that original function. If you do, it should come out a profit of $4,572.78. Alright, so that's how much money they make when they sell 9 laptops. Alright, how much profit will be lost if the sales drop to 8? So far, nothing about marginal analysis. This is just straight out, what are they exactly? So this is using your original function, no derivatives yet. And so this is just asking, well, I find my, well, what if it dropped to 8? What's the profit at 8? And then find the difference in the profit at 8 and the profit at 9. So I'm going to find that, and then we're going to take the profit at 8 minus the profit at 9, and that's how much profit we should gain or lose. I'm assuming it's a loss since it says it in the problem. And it should be, if they're selling one less item, more than likely they're going to lose profit. Alright, so though, first plug 8 into the original. So again, going back up here, no derivative yet to the original, and plugging 8 in. So if they only sell 8 laptops, they're going to make $3,978.75, so it is less. And so to figure out how much less, well, you take those two numbers and subtract them. So you're going to take your 3978.5, subtract the 4572.78, and the difference comes out to be negative 594.023. So they lose $594.03 if they drop to 8 if they drop from 8 to 9. All right, so that's exactly how much they lose. All right, C. All right, C is asking for the so here's the first marginal profit function, marginal profit example. I give myself a little more space to work. So give me a second while I didn't give myself enough space there apparently. All right, so we want to find the marginal profit at their $9, so current level of production. All right, so C, we want to find the marginal profit at x equals 9, the current level of production, and then interpret. Explain what it means. All right, so marginal profit is the derivative of the profit. And so I go back up to the profit equation. All right, so go back up here and take its derivative. So the derivative of the profit is going to come out. Negative 0.012 x to the second minus 0.6x plus 600. All right, so there's my marginal profit function. And then we're going to take our marginal profit and plug 9 into it. All right, so when we plug 9 into, again, now the derivative. All right, so we're plugging 9 into the derivative equation. It's going to come out $5,093.63. All right, so now explain what that means. All right, so I'm going to go up here and explain. I'm going to erase my previous one. I think it's easier than moving. All right, so the explain. All right, so what this is telling me is that if they sell the 10th item, 10th laptop, they will make about $593.63 in additional profit. All right, and so that's part C. All right, the last question is asking you to use your previous answer to figure out how much profit would change if they did increase to 10, right? So it's asking you to use your previous answer to estimate profit if they did increase to those 10 laptops. So D is asking you to find the profit at 10 using the marginal profit. All right, so profit at 10 is approximately the profit at 9 plus the marginal profit at 9, the additional. And we already have those. That was profit at 9 was answer A. That came out $4,572.78. So that's how much it cost them, or not how much cost. That's how much profit that you had at 9. And then about, when you, again, produce the one more, 10, they're going to make about $593.63 when they sell one more. So they go to the 10th. And so if you add those up, it's about $5,166.41. And so that's how much, using marginal analysis, what they'll make when they sell 10 laptops. All right, so this is the profit, again, approximate, if they sell 10 items, 10 laptops. This is about how much they make. Now, if you took 10 and plugged it into the profit equation, it should be close to that. All right, it should be in pennies of that. All right, so again, this is the marginal analysis, though. We're using the derivative to approximate. All right, so we'll stop the set of notes here. So this is the first part of 2.6, which is marginal cost, marginal revenue, and marginal profit. And so you should look at those particular problems in the book, and you should look at those particular problems on the worksheets. The next video that I'll do, we'll start into, so this was where we'll start part 2, the next video on differential functions and applications, and that's the next one that you'll watch. Alright, we'll stop that there. Again, bear in mind with me, guys, this is new. Videos, again, are always interesting, and hopefully you could hear and pay attention. It's a work in progress. And you can, again, like I said, rewatch videos as many times as you want, so it's kind of nice in that regard. Alright, we'll wrap it up there.